just wanted to do a brief introduction to how to how to put your data into comprehensive meta-analysis, and then I'll go over really quickly how to do the analyses there. There are more tutorials about this in comprehensive meta-analysis. There's stuff in next week's module, publication biases, about how to run all the publication biases things, etc. But let's start. Once you've downloaded a trial version or purchased a copy of comprehensive meta-analysis, when you open it up, it will look like this. And I would say go ahead and start with a blank spreadsheet. You can also run the tutorial at this point, but after watching this, you can probably just start with a blank spreadsheet. You're going to click on OK. You're going to get a spreadsheet that looks like this. I'll go ahead and make that a little bigger. There we go. So, great. Now we just have a big empty field we need to put our data in. It'd be great if you could just import your stuff from Excel, but I find that doesn't tend to work very well. So I would go in, what you're going to do instead is add rows for various things. So if you click on A, if you right click on that, it'll say identify a function for column A. The first thing I would do is put in your study names. Confirm that A holds the study names. Great. These can be your ID numbers. It wants them to be called study names. You don't get to change what all of these labels are like you can in Excel. It has very specific things that it's looking for in comprehensive meta-analysis, and you will give it those things. So that's the way it likes to run. So study name, but that can be ID number 1, 2, 3, etc. The next thing you're going to need to do is input your effect sizes. So when you go to if you right click on B, the next column, identify function for column B, we need some effect size data. Great. So click on that, and it brings up a welcome screen that'll try to help you walk through. You can use the tell me more. It'll give you more information on what you're looking for, but each one of your groups has a specific type of effect size data you're looking for. So what are we going to do? I'd go ahead and go with show all 100 formats, though most years are probably under common, but that's fine. Then you have to choose one of these things. All of you will be using the first one, a comparison of 2 groups, 2 time points, or exposures. And this includes correlations. So all of you should be using that one. You're just going to click on Next. And then you're going to look through here to figure out which one of these you're looking for. If you have dichotomous data, it's going to ask you what kind of dichotomous data do you have. Do you have unmatched groups, controlled trials, cohort studies, things like that are going to be under here. Perfect. If that's the kind of data that you have. But it's dichotomous, so it's yes-no data. So we're not talking about continuous data like means and standard deviations on things. We're talking about like recidivism data, whether or not something happened. Then you can choose from the 5 different types that it's looking for. So if you have events and sample size for each group, the event would be yes, the person reoffended, and then the sample size for the group. So maybe 10 people reoffended out of 100. Those are going to be the pieces of data you'd be looking for here. Maybe you have events and non-events. That's how you coded it. Maybe you have non-events and sample sizes, etc. Maybe all you have is the chi-square value and the total sample size. Then you could use that as well. Maybe what you have is a mixture of these. So for 9 of your studies, you actually have the events and the sample sizes. Then you could go ahead and click on that because some of your data is in that form. But for some of them, all you had was a chi-square value and the total sample size. Then you can come back and add more rows, more columns that will look at that type of effect size. And I'll do that in a minute. But let's just go ahead, and that's the one that most of the time the group that's looking at reoffense rates is going to be using. So let's go down here under continuous. We'll close up dichotomous for right now. So for the group that was looking at continuously scaled data, like if what you're looking at is pre- and post-test scores on measures of PTSD or depression, things like that, then you'd be looking at this continuous data area. If what you have is unmatched groups, but you have the post-test scores, then you're probably going to be in here. Most of the time what you're looking at is you have the mean and the standard deviation and the sample size in each group. So what was their post-test mean? their post-test standard deviation, and the n size for each one of the groups. Then you could just click on that. And let's go ahead and do that for now. Then it's going to ask you, what do you want to call these? So group A, you don't have to specify any of these, but you could tell it which cell you wanted each of these to go into. I would just let it go wherever it wants to go and just click Finish. Then the other thing it's going to ask you is, what do you want to call group A and group B? So we're going to call them treated and controlled, like it suggests, because that's usually what you have, but sometimes you might have something else, like you might have a group that had, say, hypnotherapy and a group that had traditional CBT. So you might have two different types of treatment in here, and you might want to make sure that those columns are clearly labeled so you know which treatment's data goes in which column. But if you just have treatment and controls, you can just go ahead and go with the typical and click on OK. So now you'd go in here. The data for study 1 was in this format. We have treatment means and standard deviation. Their mean for the treatment group was 12. Their standard deviation was 3. The n size was 50. The control group's mean was 15. Standard deviation was 2.8. And the control sample size was 50 as well. And the effect size direction, that's one of the things you need to think about. Are we expecting a negative effect size, a positive effect size? Where do we expect this to go? Well, in this case, we're expecting it to be negative because we expect the treatment group score to be lower. We're measuring something bad. We're not measuring happiness, which is good. We're measuring depression or PTSD or something else that we want to have lowered. So we're expecting the effect size to be negative. And then it's going to go ahead and give us the rest of that. It automatically computes the standard difference in the means, a Hedges G, etc. This is basically your Cohen's d value. Difference in the means is the actual, what is the 15 minus 12 gives you 3. So it actually gives you a difference in the means as well. So all of that looks good. But wait, some of our effect sizes weren't in this format. Some of them were pre-post tests. So we're going to come over here and say, you know what, I actually need more data for effect sizes. Let me also have unmatched groups pre-post test data. Then it depends on which one of these things you have. Most of the time, what I found for the group that was looking at this was means, oh, nope, that's unmatched pre and post. Sorry, one group pre-post is what I was looking for. Most of the time what I found was a mean, the sample size, and the paired p-value. So when you're looking at pre-post test data, you can't, you need something else. You can't just put in their pre-test scores and their post-test scores and the n size. You need something else because you need to know how correlated those scores are. Did everybody's score decrease the same? So are those scores 100% correlated? So if somebody went down by 3 points, everybody else went down by 3 points as well. Or did some people go down by 2 and other people went down by 10 and some people went up by 5 and some people went down by 17? If they're all over the place, then those two values are not correlated. Their pre-test scores and their post-test scores aren't correlated. That's going to lower the effect size. So we need to know not just what was the overall mean for the pre-test and the overall mean for the post-test, but we need to know how related they were. So what would be best is if they actually gave this information here. The means, the standard deviations, pre and post, and a correlation between the pre and post test scores. We actually have an R value for that and the sample size. I will tell you I've seen that in maybe 2 articles ever in my whole entire life. So most of the time what you're looking at is one of these two instead. Or they actually did a t-test between the pre and post test scores. Or we have some sort of p-value, either from a t-test or an ANOVA, something like that, that's looking at an actual level of statistical significance between those pre and post test scores. Sometimes we actually get an accurate p-value where what they have is it was 0.0476 and you're going to put that actual value in. Sometimes what they have is it's less than 0.05, in which case I just put in 0.049 because that's something that's less than 0.05. That's a conservative estimate. It could have been 0.0012, so it could be way less than 0.05, We just don't know. So instead, we're just going to go ahead and pick 0.049, which is something that's less than 0.05. And that's the most conservative way to estimate that effect size. So let's go ahead and pop that one in. We're going to click on Next. And again, it wants to know where you want all of this data to go. I don't care where it goes. I'm just going to hit Finish. It's going to stick it all over here. So now, perfect. Treated, control, pre, post, all happy. Click on OK. So now we have our data set suddenly looks weird. So we had this data in for independent, let me pop back over here. We had this data in for that first study. And now it has this data format thing and it says independent group means. I didn't write that there. Nope, it automatically generated that. And all of this is grayed out because that's not the format the data for study 1 was in. If we go down here, we now see we have 2 tabs at the bottom. If we click on that one, oh, that's where that data is. It all appears, it's all nice and happy. If we go back here, it all disappears because instead of having this data in that format, when we click on the paired group means, it says those gray cells, you don't need to fill those out because that doesn't apply for this study. But let's say it does apply for study number 2. And what we had was a pre-test mean of 15 and a post-test mean of 12 and a sample size of 100 and a p-value of 0.047. They actually gave us the exact p-value, so we know what that is. And it was based on a 2-tailed test. If it doesn't say how many tails, I would assume 2. That's what's most typically done. And the effect direction, again, we're expecting it to be negative because we're hoping things went down. And it goes ahead and calculates it for you. All right. So that's how you're going to use CMA to put in data. If you have multiple forms of data, if you have some in one form and some in another, you're going to end up with these tabs down here and you're going to flip back and forth between them as you enter in various studies. All right, say we also, because what we haven't talked about yet is the correlation group. So we'll go ahead and look at yours. You guys luck out, and for the most part, you have the easiest data to put in. So under correlation, what you get is computed effect sizes. You're going to click on that. And most of the time what you have is the correlation and the sample size. So we're going to go ahead and click on Next. That's fine. We'll click on Finish. Now it's given us a third tab down here. You probably wouldn't mix these 3, but it's possible. So under correlation, you're going to go ahead and put in the size of the correlation. Let's say it was 0.47. We had a sample size of 527 people, and we expect this to be positive because we were expecting a positive relationship between our 2 variables. So there we go, and it goes ahead and computes that for us. There isn't a difference in the mean, so it's going to leave that blank. Now, granted, if you were in this correlation group and you hadn't entered the other things, it would have picked different effect sizes to have here. But say you actually are just curious what the other effect sizes are. You can also come over here and identify, effect size data. So identify function for column 0, add in some effect size data. Nope, not what I'm looking for. I will figure this out. Yes. Nope. There is a way to go ahead and get it to show you the other types of effect sizes. So you could have it put up a Cohen's D, a Hedges G, correlation, a Fisher Z, everything else. But whatever one you start with, it's going to automatically give you the ones that apply to that. So if you started with odds ratios, it's going to give you odds ratios and log odds. If you start with pre and post test means or standard deviations and means, it's going to give you Cohen's D and Hedges G. If you start with correlation data, it's going to start off by giving you correlations and Fisher's Z. So the other thing you're going to need to do is for your subgroup analyses, you're going to need to add in those moderator variables. So you're going to come over here and go, okay, I need to identify another column for moderator variables. We're going to call this moderator variable, let's call it study design. And that is our moderator. The data type is categorical. And alignment is left. That's fine. I don't really care. Click on OK. And we're going to say, okay, this one was study design 1, this one was study design 1, this one was study design 2. And those could be anything. You could